All right, welcome back to Precalculus. We're going to be talking about logarithmic equations tonight, today, whenever you see this thing. So, I have notes here. Got a pen that actually works with the little pad that I have, and we'll get started with this. So, very typical, very common example, very nice way to start here is like we have log, let's see, x plus log of, let's go with x plus 15 equals 2. Now, when you've got a problem like this, the first thing you have to do is you have to take the anti-log, that's the official word, sorry, when you have a problem like this, you want to take the anti-log of both sides, but we only have to do it once. We don't want to have to like raise this to a 10, raise this to a 10, raise this to a 10. That's going to be difficult to keep all of that straight with these pluses in here. It's not really going to work out the way we think it's going to work out. So what I really want to do is I just want one log on each side here, okay? So what we're going to do is we have a formula that says log of AB is equal to log of A plus log of B. Well, this formula works in both directions, okay? So the first thing we're going to do here is we're going to say this is the log of X times X plus 15 equals 2. Now we're just going to multiply this out. We have log of x squared plus 15x, right? Because it's got to visit both of these guys. That equals to 2. Now, we have one thing inside of a logarithm at most on each side. Okay, now what we can do is unlogify this equation. Don't use that as a word. That's a word I made up. Okay, so we have x squared plus 15x is equal to 10 to the 2. That's 100. Be very careful. This is the step right here on the right-hand side, right? We take the anti-log, make sure you get it on the right-hand side. This is the place where everybody's going to mess up. But that's a property of logarithms. Like 10 to the log base 5 is equal to 5. Okay, we can check that out. Okay, we can test that out. So 10, actually one more time, 10 raised to the log base 10 of anything is equal to that anything. Now be careful, because if we want to take the logarithm first, this has to be a positive number, okay? And then you can go ahead and view that. So make sure you're giving it the correct argument, the correct thing you can put inside of a logarithm for this thing to work, okay? But we can go ahead and test this. We can say 10 caret, okay? So I already have it written up here. Raised to the log base, whatever you'd like. Okay, we'll try. We did 5. You can see the 5 is in here. Let's do 300. Okay, and what are we going to end up with? We're going to end up with 300. So 10 raised to the log base, or log base 10 of 300. What do you know? It's 300. Okay, so b raised to the log base b of something is that something. As long as this something is defined, as long as this expression makes sense, then this will work. Okay, so you have to be careful about that, but otherwise, that's how you get rid of the logarithm. Okay, logarithms and exponents, those are inverse functions. So we use exponents, exponentials, to deal with, to get rid of logarithms. We use logarithms to get rid of exponents. Okay, so at this point, it's just a polynomial. We have x squared plus 15x minus 100 equals 0. Anytime you have something any more complicated, like a linear function, you want a 0 on the right-hand side. Okay, and then we got to go ahead and factor this, and that looks like it's going to be x plus 20, x minus 5. Okay, and then we can break this apart, and we can say something clever like x plus 20 equals 0, x minus 5 equals 0. So we have x is equal to 5, or x equals negative 20. Okay, so here's my answer. Now, when you were in Algebra 1, you probably learned about rational functions, right? F of x divided by g of x, some expression equals, what was one of the things you had to check? You had to check that g of x was not equal to 0, because there's a domain issue. If you do get it, no matter what your x actually was, if you plugged it in here, you got a 0, wasn't a solution. When you had to deal with square roots of something, square root of h of x, okay, you had to check, is h of x greater than 0? 0 would be okay, but if it was negative, this didn't work. So you had to go back and check. Well, guess what? Logarithms have to be greater than 0. So if you have the log of something, j of x, whatever, that j of x has to be greater than 0. We have to check. So no matter what we get for an answer here, we have to go back to the original problem and double check to make sure, is this going to work? So if I go back to my original problem here, okay, that's up here, and I plug in a negative 20, oh, we are going to have some negative numbers in here, aren't we? So that means we can't take that logarithm. So when I try to put these numbers back in, it ain't going to work. So this is going to be a new solution. Because when I go back to the original problem statement, I put in that negative 20, it doesn't work. What happens if I put in a 5? Okay, well, we go back and put in a 5, we get log 5, that's fine. We get log 5 plus 15, that's log 20. That one works fine, just fine. So this one, that's fine, that's a solution, okay? But if you do this and you just get our two answers, negative 20 and 5, you write those down. If you're in my class, I will automatically take a grade off of your problem. So I grade by problems. So normally you would do this, you would get your answer, it'd be beautiful, it's an A for that problem. But if you don't check, automatically you get a B for that problem, okay, which is going to be 0.8 times however many points the problem is worth. Okay, so that's how I do that. So you have to check. You can tell me I checked. Okay, don't lie to me because then I might take 2. But if you check, so a lot of times writing I checked takes longer than actually checking. Okay, in this case, writing I checked took longer than plugging in negative 100 or negative 20 and positive 5. Okay, so if you write that down, I generally take it for granted. I said, you know what, if they took the time to write this down, they probably took the time to inspect their answer. Okay, but if you don't tell me that you checked, you're gonna lose points for it. Okay, because all three of these rational functions, radical functions, and logarithmic rational equations, radical equations, and logarithmic equations. You have to check, otherwise you might violate a domain. We can't have that. Okay, so you have to check. These are the 3 instances you have to check. Okay, so make sure that you're checking your answers and make sure it actually works. Okay, and pretty much all I really care about is, like, are they positive numbers? Can you take the logarithm of a positive number? Yeah. Do I care what that number is going to be? Not really. I just want it to be positive so that you can do it. You don't have to check all of your work and all of your arithmetic. It'd be nice, but I understand. We have things to do. Okay, so I'm not going to be that much of a stickler about it, but you do have to check to make sure that you're taking the logarithms, positive numbers. You have to go back to the beginning. Okay, just like Marley from A Christmas Carol, where he had to drag the chest of gold through the afterlife. Like, whatever you started with, you got to drag this initial statement through the whole problem, okay, before you're free of it. Okay, so that's how you do something like that. Okay, next problem. So let's take a look at this one. Okay, this is, I'll check my handwriting here. So we've got, hold on here, we've got log base 8, okay, x plus 6, okay, is equal to 1 minus log, okay, base 8 of x plus 4. Okay, so this is our original problem statement. So the first thing we're going to do is we're going to swing this log over to the other side. So we have log base 8, x plus 6, plus log base 8, x plus 4 is equal to 1. Okay, we have to combine this into one single logarithm. So we have log 8, and then we have x plus 6 times x plus 4 is equal to 1. Go ahead and FOIL that out. Okay, so we have x squared, 6 and 4 make 10, so we have plus 10x. Did I write down? Oh, you know what? Let me change one thing here. Let's make that a minus. Let's make that a minus. Okay, I'm sorry about that. Let's follow through and make that a minus. Make this one a minus, which means that's going to make that a minus. Let's go ahead and use a proper eraser here. All right, so we have, sorry for writing down the wrong problem, but there we go. So this is a -6 minus 4. So it's going to be a positive 24 here. That's equal to 1. Okay, so all I did, I wrote down plus, I'm sorry, should be negative. Okay, now we've got a log on one side, we've got a log on the other side. How do we get rid of the log? Well, logify it. And yeah, that's a word I made up. So this is going to cancel out. Okay, and all we're going to be left with is x squared minus 10x plus 24 is equal to 8 to the 1. It's 8. Let's subtract 8 from both sides. Subtract 8 from both sides. 24 is 8 times 3, 8 times 1. That's going to be 8 times 2 left over. So we have 16. Plus we have x squared minus 10x plus 16 equals right-hand side is now 0. Right? Can you think of two numbers that multiply out to 16 but add up to negative 10? How about x minus 8 and x minus 2? Is that going to do it for us? I believe it is equal to 0. Right now, before I go off too much further, right? Oh no, we're not. Yeah, we are. We're here. Okay, we did the logarithm. We unlogified. We're good. We're just solving this. Okay, so we have x minus 8 equals 0. We have x minus 2 equals 0. So we have x is equal to 8. X is equal to 2. Now, remember what we said before. You got to go back and make sure that all of this is going to work. What is our original problem statement, right? And you recall, okay, our original problem statement said log base 8 of x minus 6. Remember, I changed this pluses to a negative so the problem would work out a little bit better. Okay, is equal to 1 minus log base 8, okay, log base 8 of x plus 4. Or x minus 4. Okay, that's what we started with. If I put in 8, 8 minus 6 is a positive number. We're good. 8 minus 4 is a positive number. Okay, so that's going to work out. Well, what is log base 8 of 8 minus 6? What is log base 8 of 2? What is that equal to? We have to go back to equivalent exponential form. So 8 raised to the question mark, right? 8 raised to the question mark is equal to 2. 8 raised to what power is equal to 2? Oh, how about 8 raised to the 1/3 power is equal to 2? Okay. So when I go and plug this one in, okay, we plug in 8 here. We have 1 minus log base 8 of 8 minus 4. Okay. So there we go. So now we have 1/3. Okay. We have, let's put this on the other side. So we have log base 8 of x minus 6 plus log base 8 of x minus 4. I know that this piece here, when I plug in my x equals 8, and x equals 8, I know this is going to be 1/3. I know this side has to be equal to 1. So when I'm looking at this, what is log base 8 of 4? 8 raised to what power? Equals 4. So it makes sense that if I take the 1/3 power, I get 2 here. 2 squared would be 4. So log base 8 of 4 is equal to 2/3, and we would get what? Both of these solutions, or the 8 rather, in both of these gives me a positive number. What if I plug in the 2? Well, 2 minus 6 is not positive. 2 minus 4 is not positive. So this guy here, this is no solution. Okay, this piece is. This works out just fine. So this one, we're happy. Okay, but this piece, this was no solution. So that's good. We're going to discount that. Okay, so that's how you solve a problem like that. Okay, be very careful when you're looking at the other side of doing this thing. Okay, this 8 raised to the 1, that is usually the hardest part of the part. If you missed points on this, or if you missed points on your test for this one, that's probably where you're going to mess up. Okay, so try to be careful about doing that. Okay? And I think we've got one more. This one is a doozy. This one is not a fun problem. Okay, so let's see here. I have log base 2. Okay, I'm going to sneeze, so hold on for a second. All right, so this is log base 2. Okay. What do we have here? We have log base 2 of x plus 1. Okay, plus log base 2 of x plus 7. This is equal to 3. Okay, so what do you have to do here? Well, we're going to pull these guys together. So we have log base 2 of x plus 1, x plus 7 is equal to 3. So we have log base 2, x squared, 1 and 7 would make 8 plus 8x, right? 7x plus 1x plus 7 is equal to 3. How do I get rid of the logarithm? Well, we unlogify it. 2. Okay, so we're going to make both sides the exponent to the same base. Okay, we're taking the anti-log if you want to say it properly. Okay, so we've got x squared plus 8x plus 7 is equal to, what is 2 to the 3? 8. Okay, so let's go ahead and subtract the 8 from both sides. So we have x squared plus 8x minus 1 equals 0. Can we factor that? Unfortunately, we can't. If only there was a way to solve a quadratic equation, the quadratic formula, some way without factoring it. You have to remember, oh, really? Are you kidding me? X equals negative b plus or minus the square root of b squared minus 4ac. Okay, so this example is probably the worst one that you would ever see in like a pre-calculus class, simply because there's so many steps, okay? At which point, people who are grading this, you have to stop and ask yourself, like, what am I grading here? Okay, just to go back by one, this kind of problem, this is like my favorite flavor of this kind of problem. This one is a little involved, okay? So I would say, I probably wouldn't want to ask this one simply because there's a lot to this one, okay? And this is a plus here, right? So what do we have? We have negative 8, so we have x equals to something. Negative 8, right, because it's negative, plus or minus the square root of b squared, that's going to be 64, okay? Minus 4, a is 1, c is negative 1. That's another place where, wow, there's a lot of places to mess up. There sure is. Okay, all divided by 2. Okay, 2a. So we're going to have x equals, this is negative 8, plus or minus the square root. 64. Notice there's 2 negative signs here, negative, negative. So it's going to be plus 4 divided all by 2. So we're going to have x equals negative 8 plus or minus the square root of 68, right? 4 and 64 plus 4 is 68, all divided by 2. Well, what's 68? 68 happens to be 4 times 17, okay? So this is x equals negative 8 plus or minus the square root. This is 4 times 17 here. Okay, 68 is 4 times 17. Right, that's 40 and 28. That'll make 68. Okay, all divided by 2. Okay, the square root, does 4 have a nice square root? Sure does. It's 2. So this is negative 8 plus or minus. What's the square root of 4? 2. What's the square root of 17? Yeah, the heck if I know. So we just leave that as square root of 17 and sitting in there. Divided by 2. So this is x equals. Okay, but don't answer yet. We're not done yet. So this is x equals. What is 8 over 2? It's just negative 4 plus or minus and that's going to go away with that piece there. Okay, all divided by 2. Okay, so that's what our answer actually is. Okay, so we have to go ahead and figure out, like, well, is -4 minus the square root of 17? To me, that seems like that's going to be, actually, this is gone. It's not over 2 anymore. We cancel the 2's. That strikes me that that's a number less than 0. That answer is not going to work out. Okay, this is a new solution part. No matter what this is, it's going to be negative. When I plug this back into my original statement, okay, oh, actually, let's go ahead and check, because if I plug it back in, if I add it to 7, that's going to be positive. If I add it to 1, that might actually work out, right? Because we got to go all the way back up here. We got to plug it back into the x. So if I say, you know what, x equals that, what if we add 1 to it? So we have x plus 1 equals -4 minus root 17 plus 1. This is -3 minus root 17. I think that's still negative. I think that's still negative, so I don't think that's going to work out so well. So I plug this number back into my x plus 1, I get a negative number. It's not going to work. What about the other one? Right, we have -4 plus root 17. Right? -4 plus root 17. If I add 1 to this, that's going to be -3, right? For -4 plus 1, if you're $4 in debt, you pay back $1. Now we're $3 in debt. Plus root 17. Well, that is positive. Okay, so that x plus 1, that one is going to be a positive number, plus 7 is going to be a positive number, obviously. Okay, so we can say 7 plus, right? So -4 minus root 17. If I add 7 to this, that's going to be 3 minus root 17. And root 17 is like 4-ish, okay? That's going to be a positive number. So that one will work out just fine. That one will work out just fine. So this is our solution to this thing. Do I care numerically what this is going to come out to? Not particularly. But did we check it? Yes, we checked. Okay, right here, checked. When you want to see you check something, but it was obvious, say, checked by inspection. Okay, that's the fancy way to write that down, okay, to make people think you know what you're doing. Okay, but we'll say check by inspection, that'll work out, and then you're set. That's how you do that problem. This is a bit of an involved one, but everything else up here, the second problem, that would be a fair question. If you were in my class, I would ask you this, and I would not lose any sleep. I would lose a little sleep on the third problem. I think it was a little too hard. But the first one, the second one, yeah, that's a standard type of problem. Thank you for tuning in. Good luck, and do some homework.